So are we all clear on that mistake I made yesterday then, up here? All right, so the big idea yesterday was this. If we have two lines that are parallel, what's true of their slopes? They're the same, right? And if you have two lines that are perpendicular, how are the slopes related? Two lines that are perpendicular like this. Slopes will be the opposite reciprocal of each other, okay? So I'm going to clean up this example 4 quickly. We did not do this one yesterday, is that correct? All right, so let me clean this up here quickly. Oh, let me get my tools open here. Guys, this isn't going to take too long to get through today. Have some time to work on some things. Just a reminder, 4.2, that's due later today. So if you have questions, we'll get some work time in here today to have some time to see if you need to ask some questions more regarding that. I'll send out a 4.3 here in a bit. But guys, what we want to do is this. Again, don't lose sight of all the forms that we've talked about now. We've got standard form in our back pocket, slope-intercept form, which we like to represent answers in that form. And then we also use point slope form to be able to get there. So in example 4, much like example 2, we're looking to write an equation of a line that passes through which point, kiddos? 4, -3, and is, here's the big idea, perpendicular to what? Well, the line y equals 4x minus 1. So there's a line, 4x minus 1, graphed in a coordinate plane. All right, I'm not going to worry about what that looks like. What I am going to say is this. What's the slope of the given line right here, kiddos? Slope is 4, right? In this line. We want to be able to write an equation for a line that is perpendicular to that. What's up, Hal?
Who's Dylan?
Dylan? It's right there.
Paper. Because I need paper. It was in the home. Is it still in there?
What?
A paper in the home.
All right, right here. Slope is 4. Slope is 4 in this right up here, everybody. What would a perpendicular slope be then to that? Slope of 4. What would a perpendicular slope be to 4? Perpendicular slope to 4. -1/4. You bet. Isn't the slope of 4 over 1? So the opposite reciprocal that we need for a perpendicular slope would be -1/4. Okay. We're choosing the opposite reciprocal for slope because we have lines that are, that's the word here, perpendicular. Okay, which point do we travel through, kiddos? 4, comma. All right, so hey, once I have a slope and once I have a point, can I pull out that point slope form formula now and be able to go ahead and say, well, here's what we're going to do now. So let's punch it up here. I'll write the formula again. To get this to slope-intercept form, we have point slope form formula, which states this. All right, help me plug in values appropriately. Y minus what, kiddos? Y minus -3. Can I go ahead and just call that +3 right off the bat? Is that okay? We're subtracting a negative. How about my slope, kiddos? -1/4. And x minus what? 4. Right? So once I've got stuff plugged in there, we just have to chug our way through and come up with slope-intercept form. So we're going to distribute on the right first. And I've got y plus 3 on the left. Tell me if I distribute correctly. You guys agree with that? -1/4 x. 1/4 of 4 is 1. Negative times negative would make it a +1. What do I have to subtract from both sides, gang? Subtract the 3. And we finally end up with, there you go, y equals -1/4 x minus 2. Okay. Now again, your assignments, they'll check your green if you're right. If not, I'll give you the red X, but I always believe that, hey, once I get done with this, come back to decimals again, right here, and maybe look into this situation like so. And what you're going to end up doing is just plugging in all the information. Which point were we wanting our line to travel through, guys? What was it, 4, -3? Does that sound right, guys? So I would say, okay, well, let's put in that line, 4, -3. Or I'm sorry, not that line, but that point. That's what I meant. 4, -3. Plots it down here for me, doesn't it? What was the equation of the original line they gave you, guys? Is it 4x minus 1? All right, so there was the line. We had to have a line that kind of went like this, perpendicular to the blue line through that red point right down here. What did we come up with an answer? -2. This looks like it's 90 degrees here. Does it hit the point I wanted it to hit right down here? Are we right? Have to be right. Okay. Love this tool for being able to go back and verify stuff. Just love this tool for verifying stuff. Okay. Any questions about that example? Well, okay, then let's look at the last example on page, or the last page of your notes. We'll get through this, and I'm going to just kind of clean some stuff up here. Alex was here, and so was Ian, it looks like. All right. I want you guys to do this. There's a really nice story problem on page 180 of your books. I'll have you read that later. I'm not too concerned, but I'm going to kind of explain to you what's going on. Okay. The other day, we were in a gym. Okay, this might be the gym floor right here. And I said, hey, I'm going to give a prize to the first person that can run from one bleacher and touch the other side over here. First person to get to that bleacher gets prize. Okay. My first student. Okay. My first student stood there. My second student stood there, and my third student stood here. Now, when the race started, all I said is you have to run to the other side, touch the bleacher. You want to know what student 1 did? They took off and went like this. Okay. Student 2 went like this. Student 3 went like this. Student 3s were out there right now for you. All right, the question is, I don't know who won the race. I'm not going to tell you who actually won the race, okay? But let me ask you this question. Who took the most efficient path to get to the other side? 2 did. Who said 3? Your definition of most and my definition of least must be the same, something like that, all right? Why 2? Straight across, okay? Guys, if I said I had to run from the wall up here at the front of the room to the wall back there, what would be my path? I always do that. What would be my path of least resistance? Straight to it, straight to that wall, run straight to that wall. And the assumption is if I run straight to that wall, what angle is formed down here? Whoops. What angle do you end up forming down here when you run that path to? Okay, so the idea is here. When you run that, this angle that's formed right down here with line 2 in the opposite bleacher is a 90-degree angle. So we're going to start talking about stuff in terms of story problems today. We're going to talk about a path of least resistance, or the shortest path to a certain line. Okay? So the assumption being that, hey, this is a 90-degree angle, that's going to fit our perpendicular definition pretty well today, isn't it? So, in our example right here, guys, I'm going to kind of tell you what's going on in the story problem at the end of your notes. Okay, on page 180 of your books, they talk about a search and rescue going on. Sometimes the Coast Guard has to get a helicopter to go out to sea and rescue people, right? So what I'm going to have you do here quickly is the following. I want you to go ahead and just make a coordinate plane like so. All right? Make that coordinate plane. Over here, I want you to draw a line that looks like this. And this doesn't have to be perfect. Okay? I'm going to tell you right here that this part out in here is kind of like the ocean. This part out in here is sort of like the ocean. There's a boat up here. I'm going to tell you there's a boat up here that's stranded. Here's my boat that's stranded. Okay? And then over here, oops. Over here, we're going to be at a beach. Let's see, which color would be sand? That's not really good sand. I'll go with this color right there for sand. Okay, over here is the sandy beach. Okay. And that red line is going to represent like the shoreline, where the beach meets the ocean. You okay with that? All right, so here's what's happening, guys. First of all, the shoreline appears to be straight, doesn't it? Shoreline appears to be straight. I'm going to go ahead and represent this shoreline on this map by the following equation. I'm going to represent it as y equals negative 2/3 x minus 4. Negative 2/3 x minus 4. Okay? And up here, I'm going to say, you know what? This is the boat that we're trying to get out there and rescue people off of with a helicopter. We're going to say that this is out here on a coordinate 8, 5 on a map. Okay, we want to go ahead and get to that right there. All right, our job then is to rescue those people and get them back to the shore as quick as possible. Our job is to pick those people up and get them back to shore as quick as possible. So this would be an idea or an application where you would want to take a path of least resistance. If I'm taking that path of least resistance to get back to the shoreline, what angle needs to be formed between my path and my shoreline? 90 degrees. So if you can imagine this right here, the path that we want to be able to take, I'll do my best to draw a 90-degree angle through those. You guys agree that that's the path that I would fly on to get back to the shoreline right there at 90 degrees? Okay, we need to come up with an equation. Now this looks like a total mess, okay? Looks like a total mess. My kids can do artwork better than that. But do we know enough now about the relationships of slopes of perpendicular lines and given a point to be able to write an equation for that path of least resistance now? Listen to these words you're listening to. I'll bet you some college kids don't even hear some of the stuff that you're getting today. How about the slope of my path of least resistance? First of all, is it positive or negative, guys? Positive, okay? So how is that slope positively going to relate to the slope of negative 2/3? What's the slope of my new line going to be? Okay, so what is that slope going to be, Tori? So my slope that I want, m, is going to be 3/2. Okay. Which point do we have to pass through? Where do we pick up the stranded boaters? 8, 5. So I'm going to give myself a little bit of room to work this. You've got a point, you've got a slope. Can't we use point slope form here now to go ahead and write an equation for this? We can. So let's do that. Let's do that. So here we go. Y minus the y1 value. Oh, that's really messed me up. That was the ugliest y I've ever seen. Y minus, what's the y value that we're passing through? Y minus 5 equals your slope of what value, kiddos? 3/2 times the x minus the x value at the point you're at. 8. You guys got this. We're doing awesome here. I love it. I'm going to distribute. You help me distribute. Got 3 over 2x. Let's see. The 3 over 2 times the negative 8. How about 8 divided by 2 first? 4 times 3? 12. So minus how much here? Okay. Finally, in the end, add what?
5.
So when I add 5 to this right here, we end up with what? Equals 3 halves x minus 7. And that would be the path or the line on that map for the helicopter we want to fly to make that the shortest path back to the shoreline. Okay? So if you ever see a problem in any of the assignments here that says about getting back the shortest route, you're looking for an equation that's perpendicular to a given line. All right? Okay, a lot of stuff going on here. Good stuff. Questions about anything in your notes? Here's what we're going to do. I'm going to hand out a take-home quiz, like a big take-home quiz over sections 4.1 through 4.3 that will be due Thursday. And if you get it done, great. If you don't get it done, great. Spring to me whenever you know you've got a busy schedule. Okay. I'll hand that out here in a second. We've got a short, quick quiz, and then I'm going to get you to the new book page here. So, first of all, do you guys have everything down in the notes? Who would be willing to let CJ borrow notes so that he can get stuff down this morning? Or you can go to YouTube if you want. They're on there too, CJ, as well. I'll go ahead and stop this here.